Hello and welcome to my channel. I am Mr. Eid and I teach mathematics in high school. And this is part of a series from first principles, from the very first thing you learn in algebra to you reach the point where this is solving quadratic second degree equations. And this is lesson number 2. This is part 2 of this series. Give us a like and a follow and join our Discord. We stream on Twitch as well, so join us live and come with your questions. And if you have any homework, any difficult thing, I can explain it one more time for you. So first lesson, we saw the remarkable identities. And if you want to know what that is, just click on the first lesson above this one. Now, how do we use this for factorization? First of all, what is factorization? Let's remember. Factorization is writing in terms of factors. And what are factors? Factors are just groups of things multiplied by each other. So this is factor number 1, this is factor number 2, this is factor number 3 here. Okay, that's what I'm looking for. I'm looking to write something as a product of factors. So the simplest example is, let's say, 5x plus 20. Okay, and 5x plus 20 is easy to factorize because if I write 5 multiplied by x plus 4, I have achieved my goal of writing it as a multiplication of things. You can tell me, well, there's a plus here. Yes, it's inside the bracket. It doesn't count. Okay? When the plus is inside the bracket, it doesn't really make a difference because this is a term now and this is another term. Sorry, they are the same term. What I meant to say here, this is a term and this is another term here. Okay, so they are separated by a plus. If I want to multiply, I can multiply here alone and here alone. Whereas here, if I multiply this, I'm multiplying the whole thing. They are linked with multiplication. And that is what factorization is. So let's say 3x plus 9 is also equal to 3 factor of x plus 3, let's say. Okay, that's another factorization. Now, things get tricky when we involve higher degrees. So let's say x squared minus 25. And I want to write this as a product of factors. If you're going to look for something in common between these two, you're not going to find it. X, I don't know what x is. 25 is 5 squared. That's all I know. So that's what I'm going to write. But that doesn't solve my problem at all. Or does it? Because I know in my memory, we discovered last lesson that I have a squared minus b squared equals to a minus b into a plus b. Okay. And so here, if you look, you can see that the a is our x and the b is our 5. So this is nothing but x plus 5 into x minus 5. That is the factorization. And I used my deck here, remarkable identity. I used my remarkable identity that I memorized or I derived in the first part to reach this conclusion here, right here. And again, this is not achievable any other way. And if you look, this is multiplication. They are linked with multiplication. This is a factorization, very legitimate one. So that's case number 1. Case number 2 is, let's say, x squared plus 6x plus 9 equals, and I want to factorize that. Again, if you start looking for common factors like we did here, you will never get the solution. You will never get the solution. There's nothing in common here. Oh, there's a 3 here and a 3 here. Yes, but there's no 3 here. Ah, look, there's an x here and an x here, but there's no x here. So I see most students start doing this. So x into x plus 6. And then they stop. They don't know what to do because then what do I write? 9 divided by x? So that 9 this times this gives me 9. This doesn't work. This is ugly. This is disgusting. Okay. Again, I'm looking for clues with my remarkable identities at this point. And the only one I can remember is a plus b, the whole thing squared for this. It's equal to a squared plus 2ab plus b squared. That's what it's equal to. So I'm gonna look here and I'm gonna copy. Let's see if it applies. Okay. X squared is a squared. That's fine. B squared should be a 9. Is 9 a square? It is. That's very good news. Now, can this term be written as 2 times something, which is this times this here? So if I postulate that A is equal to X and B is equal to 3, because B squared is 9. Okay, this is what I'm thinking. Can I write 2 times something, 2 times A times B for these two here? Well, 6x is equal to, let's see, 2 times A, which is X, times B. This is 6x. So we have this done. It's the same one, right? So here I can simply copy. This is A plus B squared. What was B? B was 3, because B squared is 9 here if you look. So B was 3, and then what was A? A was X. And if you want to check your work, all you have to do is just expand this again. So you will get the square of the first plus 2 times the first times the second plus the square of this one here. And this gives what we started with. So this is the second remarkable identity coming in handy here. Again, you're going to ask me now, oh, but this is not a factorization. Look, we wanted a product of things, but this is just a square. Well, if you remember from part 1, this is only what it is. This is what a square is. This is what the square is. It's just the product of two things. The thing in itself. So it qualifies. Okay. So this is case number 1. And this is case number 2. There are 3 remarkable identities. Let's do the third one very quickly before we finish here. The third example. So this is x squared minus 4x plus 4 equals. And I need to factorize. I need to write in terms of factors. This time, I have a minus b, the whole thing squared in my mind. And this is equals what? This equals a squared minus 2ab plus b squared. Okay. And if you look here, a squared is indeed x. B squared is 4, so b is 2. And then 2 times 2 gives me 4 here, so I am very fine in writing this is x minus 2. Why minus? Because there's a minus here, right? This is the minus that I'm looking for. So x minus 2, the whole thing squared. And is this a factorization? Yes, of course, because it's x minus 2 times itself. That's how you use factorization for quadratic equations that look kind of difficult to do. Okay? It looked intimidating at first. There's nothing in common here. There's nothing in common here. There's nothing in common between all these here. But it turns out that there is a factorization. So enjoy. This part is over. Go practice at home and see you in the next video. Join our Discord. Join us live on Twitch. Follow the channel. Take care.